So generic four-step process 4. So before I ever tell you anything about what we're doing, in the top right-hand corner, I want you to write what things. I need to know what number this is, and this is which one. This is the third one we've done. And what chapter does it come from? It helps a lot just keeping everything in order. And again, I have 75 or something of these, so make sure that you write your name on it somewhere. So this is the generic four-step process 4. And I don't expect you to know this part yet. I'm just telling you this. For a one sample confidence interval for means. Well, if you have any sense, you can guess different things that are going to happen. Why do I say one sample? Because probably eventually we're going to deal with what? More than one, we're going to deal with 2. We're actually going to change that we're not dealing with confidence interval, but then more specifically, the part that you should know, we're starting with means, but we're also going to do it for proportions. So just so that y'all see why I'm writing that stuff and what's going to be different. So state. Now, usually we start by doing what is our first 3 things in state? Population, sample, and then define our mu. I'm not writing any of that, but I'll show you why. So I want you to start with, we do population, sample, define your parameter, and then say what it is that we're trying to accomplish. So we're going to start with what we want to do. So our whole point is trying to estimate the parameter. So we want to estimate, right now, because we're dealing with means, we're trying to estimate what symbol? Mu. I'm writing that in a different color, but not putting it as like multiple options, just because like eventually that could be something else. But for this sheet, that's the only one that's going to be there. Which is the true. And again, right now it's mean, but that could change. And then in context, and I want to do it, I want to estimate that value for who, which is what's going to go here. And then if I'm doing a confidence interval, I have to specify how wide of a confidence interval I want. So I have to say what my confidence level is going to be. Now, some people out of habit choose to just write up top what their population sample is, and that is fine. Why do I not write what my population is separate? Because we do it right here. Why do I not define what my parameter is? Because I do it right here. And then with these, just like from Monday, theoretically, our sample isn't context different than the population. It's just ones that were randomly selected from the population. So we kind of do it to where everything is within that one thing instead of having to write it out separately. We're still encompassing everything. Anybody still written this? Good to switch. All right, so then we go to plan. Plan switches up a little bit, so I'm going to do more of the talking than asking you what to write. So we start with the method. It should make sense to you why I'm calling it method. Which is a one sample again, I'm putting the word one in a different color, but not giving you other options because for this sheet, that's our only option. But eventually we'll have different ones there. I'm writing that it can be a Z or a T, even though we've never talked about T yet. And then specifically, this is an interval for means. Now, the one thing that's going to have to go with this is we have to write why we choose which one. And so this is in red because it always goes here. And we'll write since our sigma is or is not known. So we started talking about the other day, I said, okay, it seems kind of weird that we're estimating the population parameter, but we have no idea what sigma is, but we know sigma miraculously. This is kind of that scenario where we start to talk about that. All right, so then we actually get to checking conditions. So method is how we're going to do it. We're used to checking conditions within plan, so we're also going to do that. Now, the one thing that I've talked about a lot as we've gone, but not really, just kind of in passing, is I keep saying random's probably really important. We just haven't gotten there yet. What we've done with to this point is like we're selecting people based off of a certain thing to basically see if they're biased. Well, now we're not. Now we want to specifically randomly select. And we have two different types of randomization that are extremely important to differentiate between the two of them. Is whether, what if it can be, I can randomly what? Like think about like an experiment. I can randomly, what can I do random? What? So I can do random assignment, or I can do it with like how I pick the people, and I can do random sampling or selection, which is the same thing. So you have to specify random assignment versus random selection. Put specify which. So normal is still there. And some people write at the bottom and some people already write at the top, and I don't care which way you do it, but we always have how we can use the normal approximation. So I'm saying that if it's one of our options, what's our first way to see if it's normal? What's our easiest way if I'm dealing with means? And if it's given that what is normal? So given that the population distribution is normal, what's our other way? And what do I check for central limit theorem? N is greater than or equal to 30. And I want you to write that there's a third one, but we're not going to write that in right now. We have a third option, we just haven't gotten there yet. So what is something that is a condition that I know I checked, but I haven't checked it yet? What's the other condition? 10% condition. This actually checks to see if we can use the fact that they are independent. So it does 10% condition covers two things. It covers the fact that we can use independence, and it covers the fact that we can use the standard deviation of the sampling distribution. And so all of this is the same as it usually is. 10% condition, which is capital N greater than or equal to 10 lowercase n, and write out in context. And that's the end of plan. All right, so do. I'm going to write down symbols that numbers that are probably going to be given in the problem. If I'm dealing with means, what's got to be given to me? That's what I'm guessing. So I won't know mu, but I will know.
X bar.
So we'll know X bar. If I'm given a mean, I'm usually also given a what? And we haven't talked about being given sample standard deviation as opposed to population standard deviation, but we will get that option eventually. What else does every problem give me? What else does every problem give me? How many? And with this specific chapter, all the problems I have to know what kind of interval I make, so I need to be given the confidence level. And I use that confidence level to find my critical value, which is either going to be a Z or a T. And then so I'm writing my very generic that we talked about here. Your equation is taking your point estimate plus or minus your critical value times your standard deviation of, in this case, would be the standard deviation of X bar. So depending on if we're using Z or T, if we're using Z right now, because that's the one that we know how to use, we would take X bar as our point estimate, plus or minus our Z times sigma over square root n. Our point estimate is our sample mean, our critical value is our Z. How do we find standard deviation of sample distribution of X bar? We'll take sigma over square root n. The only thing that changes when we're going to use our other one is instead of Z, we would use T, and instead of sigma, we use S. I'm only writing this in right now so that I don't forget to go back and do that one. You shouldn't, I don't need you to feel okay about that yet. And then we're trying to estimate what parameter, our mu, and our mu is going to be between a lower value and upper value. That little table right there. So our conclude is just actually going to be the confidence interval interpretation, but I need to say stuff first. So I am not going to be here tomorrow. So I'm going to give you a sheet for tomorrow. Just like I've done before, I can teach you the generic version first or start with an example and then go back to generic. So in my 6th period today, I'm going to do a specific example. And then so your notes tomorrow will be watching their specific example from what I record today. And then, I'll post whatever else we're supposed to do for today. But I'm gonna keep talking so I can finish the video. This is your worksheet for tomorrow. Either grab it now or grab it before you walk out. I'm gonna keep talking and write out my last conclude so that I can stop the video after there. But just make sure y'all have it. Now, tomorrow, if anybody is, I need y'all to help me with this part. If anybody's not here today, I'm gonna post right here, the blank and that worksheet. So if anybody says, I don't know what it is, I wasn't here, just tell them to come grab it off the board. And this way, when the bell rings, y'all can just get up and leave. So, conclude is our exact same sentence from our interpret, and interpret the confidence interval, not the confidence level. So we are confidence level percent confident that specifically right now we can build different parameters. That one is mu right now, which is the true. Again, just for this sheet, we're dealing with mean. In context. And then falls between our lower and our upper.